Hello students, like I told you in the previous lecture, now that we have finished chapter 6, all the exercise sums, we start with miscellaneous exercise 6 actually. In the first question, now what has happened is that many of the sums of miscellaneous exercise have already been done in the exercise. So we may have a few sums less to do over here actually. Question number 1, choose the correct alternative. MCQ questions. In that, the first 4 sums have already come in the exercise. So they have already been dealt with in the previous lectures which are there. Question number 5 and 6 are very easy. You can try them out as assignment. Once you go through the previous lectures, you will know how the sums are done. We start with question number 7 actually. The question is integral 0 to 2 e raised to x dx is equal to dash. Now solving this, the integral 0 to 2 e raised to x dx can be solved as e raised to x, because you know that the integral of e raised to x is e raised to x itself. So e raised to x from 0 to 2 comes out as the answer. So as usual, we put the upper limit over here. So we get e square minus e raised to 0. And therefore the answer, anything raised to 0 is 1. So we get the answer as e square minus 1. So now what you can do is you can just open the textbook to page number 149 and check it out whether the answer is coming, which is the correct option. That much you can check out and see. Question number 8 is an assignment for you. We go to question number 9. 8 is just a sum which involves formula. Just formula you have to state over there. So that much you can do as an assignment. So question number 9, the 9th MCQ that is there. The question is integral minus 7 to 7 x cube upon x square plus 7 dx is equal to dash. We have to find the answer. Now in this case, according to one of our properties actually, when we see the limits as minus 7 to 7, we can check whether the function is an even function or an odd function. Okay, so I hope you remember those sums which we had done, wherein we write fx. Okay, let fx is equal to x cube upon x square plus 7, and therefore f of minus x becomes minus x the whole cube upon minus x the whole square plus 7, which comes out as minus x cube upon x square plus 7, and this is the same as minus f of x. So therefore we have f of minus x is equal to minus fx, and therefore we say that fx is an odd function. Fx is an odd function. So in such functions, okay, when the function is odd, what happens is that the integral a to b, that is minus a to a, fx dx becomes 0 when fx is an odd function, that is it. So therefore our question, that is the integral of minus 7 to 7 fx dx, that is x cube upon x square plus 7 dx, this function being an odd function, the answer comes out as 0. So 0 is an option in your MCQ. So that you can write as the answer over there. The 10th MCQ has already been done in the exercise. So we go on to fill in the blanks. In fill in the blanks also, you will find that most of the sums have been done already in the exercise. Only the third fill in the blanks is there, which we are going to solve just now. The question is integral 0 to 1 dx upon 2x plus 5. Okay, you know that the integral 1 upon x dx comes out as log x plus c. Okay, this is the formula which we have learnt. Over here, 1 upon 2x plus 5 can be written as log 2x plus 5. Okay, so here the answer comes out as log 2x plus 5 from 0 to 1. Okay, but this is not the correct answer, isn't it? It is 2x and not x as it is given in the formula. Okay, so as a result here, okay, we write upon 2. Now putting the upper limit of integration, we get log of 2 into 1 plus 5 upon 2 minus log of 2 into 0, the lower limit, plus 5 upon 2. Now we can take 1 upon 2 common outside as well. So over here, okay, we are going to get 1 upon 2, taking it common outside, we are going to get log of 7, 2 plus 5, 7, minus log of 5. So our answer comes out as 1 upon 2 log of 7 upon 5 over here. Okay, so this becomes the answer for the fill in the blanks, fill up that is it. Now, going further, we come to the third question. As I told you, most of the sums of fill in the blanks, almost all the sums of fill in the blanks are already there in the exercise. So you can refer to the exercise sums and see, okay, how to do those sums. Now we come to true or false questions. The third question, state whether the questions are, whether the following are true or false, that is it. Now in this, the first one, the integral a to b fx dx is equal to the integral minus b to minus a fx dx. Is it true or false? Now, the integral a to b fx dx can also be written as minus integral b to a fx dx. Okay, similarly, the RHS, that is the integral minus b to minus a fx dx, is the same as minus, if you take a minus sign common here, minus b to a fx dx. See, this is the second term that is there. So from 1 and 2, we see that both these terms are equal. Both these terms mean the same thing. As a result, our answer over here is true. Now, we go on to the next sum. The second sum. Now, the second sum, the third sum, etc. I leave it for you because these are just properties. If you see the second and third sum, okay, these are just basic properties which are already given in your lesson. Okay, you can refer to the properties and state whether the properties are true or false. That is it. Okay, if you look at the sums, you'll understand what it is. So, second sum and the third sum, you can do it as assignment. Now, what about the fourth sum? In the fourth sum, they have given integral a to b fx dx is equal to integral a to b f of x minus a minus b dx. Now, over here, according to a particular property, we have integral a to b fx dx, which can be written as integral a to b f of a plus b minus x dx. Okay, this is what the property is actually. That means this property is wrong. So the statement which they have given us is false. Over here the answer comes out as false. Okay, keep that in mind actually. Then moving on to the fifth question. The fifth question is actually this way, that is integral. Okay, I have written the sum here already for you and kept it. Now the fifth question, let me explain first of all how to do that sum. Okay, in this case, you observe that the limit of integration is minus 5 to 5. So when you do such sums, the first thing that you check is whether fx is even or odd function. You know how to check it, isn't it? Suppose fx is the question. Okay, whatever question is given, you first find what is f of minus x. Okay, by putting x as minus x, you get f of minus x. And suppose f of minus x comes out as minus fx. Then fx is an odd function. Okay, or on the other hand, if f of minus x comes the same as fx, then fx is an even function. So in this way, you check whether the function is odd or even and then you conclude accordingly. Okay, so that is how you can do the fifth sum. So fifth sum, I leave it to you as an assignment. the 6th and 7th sum are already done in the exercise. So you can go to the exercise and see how the sums are done and compare whether they are true or false. Okay, we come to the 8th question. The 8th question, integral 4 to 7 11 minus x the whole square upon 11 minus x square plus x square dx is equal to 3 by 2. So we are going to see whether this is true or false, that is it. Now we know a property whereby the integral from a to b fx dx can be written as integral from a to b f of a plus b minus x dx, isn't it? So we use this property over here to simplify this sum. So as a result, our integral I becomes this way. Now let us write the question as I over here. Those who are thorough with the formula will know why we are writing the question again. Okay, let this statement be 1. Now by property, okay, property, I think it is 5. Okay, we have 4 to 7. You can check it out and check whether I'm right or wrong. I don't remember the number of the property. Okay, over here, integral 4 to 7, we can write this as wherever x is there, we put a plus b minus x, that is 4 plus 7 minus x. So over here, 4, that is 11 minus 4 plus 7 minus x. Instead of x, we put 4 plus 7 minus x, the whole square. The whole upon, again 11 minus x is there. So 11 minus 4 plus 7 minus x, the whole square, plus, again the whole thing is squared over here, plus x square. X square is again 4 plus 7 minus x, the whole square dx. Okay, which comes out as, over here, let me write it in the next step over here. So over here, it comes out as integral 4 to 7. 11 minus 4 plus 7 is 11. So 11 minus 11 becomes 0. And minus x the whole square is x square. Upon, again in the denominator, these two terms go away. So x square plus 11 minus x the whole square. I hope you remember that we have done this type of sum earlier also. So I becomes this way. So we write this I as 2. Now adding 1 and 2. So adding 1 and 2, we are getting I plus I, that is 2I, is equal to the integral, that is 1 becomes our question. The question is actually over here. The question is 11 minus x the whole square upon 11 minus x square plus x square dx from 4 to 7 plus the second term, that is integral 4 to 7 x square upon x square plus 11 minus x the whole square dx. We see that the denominators of both the fractions are equal. The limit of their integrations are also equal. So we can combine them by putting them under the same limit of integration, and therefore we get 2I is equal to integral 4 to 7 11 minus x the whole square plus x square, because the denominators are equal, upon this way. And now we cancel out the numerator and the denominator, and thus we get integral 4 to 7 1 dx. Upon solving it, we are going to get x from 4 to 7. Okay, we are going to get x from 4 to 7, and therefore 2I becomes, now applying the upper limit and the lower limit, we get 7 minus 4, which is 3, and therefore I is equal to 3 upon 2. That means the statement which they gave us is true. Thus we find the answer. Remember, true or false also you cannot memorize the questions. You have to solve and see the questions itself actually. Now we go to the next question. Question number 4. Okay, some of the sums at least we can deal with from this particular question. Now this question is important because most of these sums can come to you for 3 or 4 marks in the exam. So in solve the following, again the first sum has been done for you in the exercise itself. We go to the second sum, second question. The integral 1 to 2 x plus 3 upon x into x plus 2 dx. Now in this case, it has to be done by the method of partial fractions. As you can see in the denominator, if you're thorough with the previous lesson, chapter 5, you will know that this has to be solved initially by partial fractions. Okay, so here we write let x plus 3 upon x plus 2 as a upon x plus b upon x plus 2. I do hope you are remembering this. Okay, so here therefore upon taking the denominator on the RHS and multiplying, we get x plus 3 is equal to a into, when we multiply a with x into x plus 2, x gets cancelled. So we get a into x plus 2. Same way, we are going to get b into x actually, because x plus 2 gets cancelled there, and therefore we get b into x. By cross multiplying we get these terms. Then what is the next step? Yes, we write let any one term, say x plus 2 is equal to 0, and therefore x becomes minus 2, and that is how we put minus 2 in this particular equation, and so therefore we get minus 2 plus 3 is equal to a into minus 2 plus 2 plus b into minus 2. Okay, minus 2 plus 2 being 0, this term goes away. So we get 1 is equal to minus 2b, and therefore b is equal to minus 1 upon 2. So thus we got the answer for b. Now let the other term is x. Let x is equal to 0. And therefore this particular term, okay, becomes now 0 plus 3. Okay, so this particular term becomes 0 plus 3 is equal to a into 0 plus 2 plus b into 0. Now b term goes away. So we get 3 is equal to 2a, and therefore a becomes 3 upon 2. Now further, if you remember how to do, we substitute a upon x plus b upon x plus 2 as our integral that is there, as our question that is there. So our integral becomes a upon x plus b upon x plus 2. So therefore our integral becomes, this sum actually. Okay, let me make it more neater for you. So over here I is equal to a upon x. So 3 upon 2 upon x. The integral, the limits of integration are from say from 1 to 2. Okay, and plus b. B is actually minus 1 upon 2. So minus 1 upon 2 upon x plus 2. Okay, the whole into dx. Upon doing this now, we can separate out the integrals over here. So we can write here integral, that is 3 upon 2, integral 1 to 2, 1 upon x dx, minus, over here this minus is wrong, over here I already put the minus sign over here. Okay, so minus 1 upon 2 integral 1 upon x plus 2 dx. You know that integral of 1 upon x is log x. Over here the limits are 1 to 2 again. So over here in the first answer we get log x. So we are getting 3 upon 2 log x, okay, log mod of x from 1 to 2. Minus 1 upon 2, again we get log x plus 2 from 1 to 2 again. So this is how we get our answer. Now to modify the answer and write it in a proper manner. Okay, now the next step becomes applying the limit of integration. So we get 3 upon 2 log of 2 minus log of 1. In this case, in the first case. And in the second case, minus 1 upon 2 log of 2 plus 2 becomes 4. So let us write the 2 plus 2 over here. Minus log of 1 plus 2. Okay, upon putting the limits of integration, we get this term. Then we can write this as actually 3 upon 2 log 2 minus log 1 becomes log 2, because log 1 is 0. So this becomes log 2 itself. minus 1 upon 2 log 4 minus log 3. Okay, and you know that when we subtract logs, okay, when two logarithms are subtracted, we can combine them and write them one upon the other. The first log, the first number upon the second number, log of that can be combined. Okay, so I hope you understood what I'm meaning over here. So as a result, we get over here 3 upon 2 log 2 minus 1 upon 2 log 4 upon 3. Okay, now now just observe what is being done over here. Okay, so now this term, okay, let me write it up over here. Okay, now this term can be written as 1 upon 2 taken outside common, and we get 3 log 2 minus log 4 upon 3. Okay, just to get the answer which they have given in textbook, all these steps are being done. Okay, which comes out as 1 upon 2. Now log 3 log 2 can be written as log 2 cube. Okay, 3 goes up as the power. This 3 goes up as the power. So log 2 cube minus log of 4 upon 3. Okay, which can be written as 1 upon 2 log 8 minus log of 4 upon 3. Okay, and then in the next step, now we combine the logs and we get 1 upon 2, that is log of 8 divided by 4 upon 3. Now we won't write divided by 4 upon 3. Yes, we'll write into 3 upon 4. Okay, so log of this now, combined, logs have been combined here. So thus we are going to get over here 1 upon 2 log 6, and this becomes the answer for the integration. In the third question, we have integral 1 to 3 x square log x dx. As you can see, there are two terms. So we use the formula u into v for integration, u into v dx. Okay, so integral u into v dx becomes u integral v dx, just to remind you of the formula, minus integral of d dx of u into integral of v dx dx. So this is the formula for u into v. You also know that, you also will be remembering that when u into v is given, we have to decide what is u and what is v. And we decided using LAE, where L stands for logarithm, A an algebraic expression, and E stands for exponential term. In this case, a logarithm is given here, log x is there, so log x becomes u, x square being an algebraic term becomes v term. So our integral I is equal to integral 1 to 3 log x into, just to understand, log x into x square dx. Okay, this way we write. Now applying the same formula, we get log x integral 1 to 3 x square dx minus integral d dx of log x from 1 to 3, of course, integral of x square dx the whole into dx. So this completes our formula actually. Now applying that formula there, we get log x into x square dx becomes x cube upon 3. So we get over here log x into x cube upon 3 from 1 to 3. So this finishes the first term actually, minus integral d dx of log x is 1 upon x. The differentiation of log x, you know, it is 1 upon x. And integral x square dx becomes x cube upon 3 dx. You know that the sum is not complete because we have not removed this integral sign. So we cancel out this x and x square, x cube term that is there. Okay. And in the next step, the first term remains as it is, log x into x cube upon 3 from 1 to 3 minus, now here we can take this 1 upon 3 common outside. So 1 upon 3 integral of 1 to 3 x square dx. Okay, and therefore going further, we are going to get the first term I am writing as it is, Okay, and in this case 1 upon 3, and solving the integral we get x cube upon 3 from 1 to 3. Thus we solve the integral. Now to write it in a proper manner. Now to write it in a proper manner, what we do over here is that, see, it becomes now x cube log x upon 3 minus x cube upon 9. Okay, the limits are common. From 1 to 3 we are getting. Now then in this case, okay, what we can do is we can equalize the denominator over here. We can just equalize the denominator, and so we are going to get 3x cube log x minus x cube upon 9 from 1 to 3. Okay, of course we cannot cancel this out. That is wrong. Okay, don't even think about it. And therefore, in the next step, suppose we take 1 upon 9 common and then apply the limit of integration over here. Okay, we first put x as 3. So we get 3 into 3 cube log 3 minus x cube becomes 3 cube. This is the first term that we are getting. Minus, now we put x as 1. So we get 3 into 1 cube log 1 minus 1 cube. Okay, so this is how we get the terms. Then in the next step, we are going to get 1 upon 9. 3 cube is 27. 27 3s are 81. So we get 1 upon 9 into 81 log 3 minus 3 cube becomes 27. And in the next step, log 1 is 0. Okay, log 1 is 0. And therefore 0 into this term just goes away. So we're going to get minus into minus plus 1. So we get 1 upon 9 into 81 log 3 minus 26. So this can be written as the final answer, or if you want to get the answer same like textbook, what you do is you divide both the terms by 9. Okay, so we get 81 upon 9, that is 9 log 3 minus 26 upon 9. So this becomes the answer over here. Okay, so we have done enough number of sums today. So we stop over here. In the next lecture, we will continue with the miscellaneous exercise 6 and complete the remaining sums which are there. Remember students, these sums can come for you at least for 3 to 4 marks, whatever sums we are doing just now. So meet you in the next lecture. Thank you for listening to me. Do subscribe and like the channel. Bye students.